Hey y'all, welcome to the channel. I'm back in the shop. We're here today talking. You can call me Guy. And if you want to weld like the picture you clicked on, well, stay tuned because I'm about to tell you how. This is going to be part 2 of the welding video, and we'll make a playlist out of it so you can check it out. And we'll also link it up top in the video, and it'll be down below in the description so you can go back and watch the first part if you haven't seen it. So part 2 is going to be about the welding itself. Alright, we're going to break it down. To start off with, you watch roughly 15 seconds of the first part of the weld, and then 15 seconds of the end of the weld, sped up times 10. So those welds are roughly 45 seconds to a minute apiece. So you saw how long that weld took. Now this little machine right here, Lincoln Square Wave 200, I'm sure you saw in the video, is what we were welding with. It held up weld after weld after weld. There was a few stops in between on some of them, but she held up the whole time and never tripped the duty cycle sensor. Now I'm not going to go over the settings on the machine that I used because I probably didn't use the settings that I should have. I used the settings that work for me, okay? Somebody's going to recommend that you use a different setting, I'm sure. This is the setting that I played with, I liked, and this is what I used. I'll go over that in another video when I do a review on the Lincoln Square Wave 200 itself. After having it a while and using it, everybody wants to do a brand new unboxing. Here it is, 2019, a couple years later, and I'm going to do a review on how it's lasted. I have not seen one of those videos yet. If you have, comment down below and let me know so I can check it out. Also remember to hit that thumbs up button at any time during the video. You can click the little red button in the corner of the screen or down below in the video, and you can be a sub. Now, although I'm not going over the settings on the actual machine, I will break down the equipment itself. And on the TIG torch, well, we were using 1/8 everything. 1/8 tungsten cotton body, we were using a long tail, and we were using a number 8 gas lens. Now, I do recommend getting a gas lens. I prefer a gas lens. We can save gas. As some of y'all know, this thing's a gas hog, and I like to keep my CFs down low in order to save on gas. Well, that gas lens makes up for the low amount of CF by pushing more out and more coverage area over the weld. So I do recommend, if you're thinking about upgrading to a gas lens, go for it because I love it. I do. So, another piece of equipment you saw in the video, you saw down below, was a grinder with a wire wheel on it that I was using to clean up. What you didn't see was the grinder back over in the corner over here. Had a grinding wheel on it that I was grinding my tungsten on. Now, for that, I was using a Hercules from Harbor Freight. I love it, with the locking trigger. The locking trigger allows me to lock it in, and I can hold it and grind my tungsten down. Unlock it to cut it off. With my quarter cable that I also use, that had the wire wheel on it, that's a dead man trigger. You let go of it, it cuts off. It's kind of hard to hold and push trigger and sharpen at the same time. So again, I love the Hercules. There will also be a review on that coming up because I love it, and so will you. Now let's go over the welding. Now I started in the top right corner above the rivet. I started my arc, I started my puddle, and I worked my way down into the rivet. By doing this, I created a little cleaning action up at the top, also transferring heat. So as I worked my way down towards the rivet, as I welded down towards the rivet, I was transferring heat from the boat itself to the aluminum rivet, kind of preheating it so that when I got to the rivet itself, it would go ahead and melt and fuse in like it was supposed to. So you may be asking, well, why didn't you just weld the rivet? Why didn't you start arcing on top of the rivet and melt it and fuse it, and then weld on top of it? Well, when you go to arc off directly on top of the rivet would instantly melt and push through to the other side. And what you didn't see on the other side, one, it was either holding a cross member, or two, it was holding part of the seat in place, and when that melted through, there was nothing holding it. So we wanted to start in the corner and work our way to it and do it the proper way. Now I've done many of these rivet welds on many other boats coming along the way. Usually when they bring them in, they have 1 or 2, maybe 3 of them that are leaking, and I'll weld them up and I'll grind them down smooth, right? Sounds good, ship them out the door, it looks good. Not only that, but when you grind it down smooth, there's less friction in the water. The smoother the bottom of the boat, the easier it glides across the water. As I said, I've done many of these before, but normally they only come in 1, 2, maybe 3 at a time. Well, this time we had to do almost all of them on the bottom of the boat. He wanted them all welded up, sealed, that way he wouldn't have to worry about them later. And what we found out when welding on it, well, the ones that didn't have a leak or had very little water that would seep through when you filled the boat up, well, those welded perfect. When you started at the corner, you welded in, and as you got to the rivet, it would heat up and fuse in like it was supposed to. Well, the ones that had the big droplets of water coming out of it, and one of them actually had a pretty steady stream coming out, well, as you were coming in, there was enough gap in there to where the rivet itself was not heating enough for me to start welding as I was coming in to the rivet. So when I started in the corner, I came in, and I guess the air gap, the sludge, whatever had gotten in there over time, created a little gap, and the heat wasn't transferring like it was supposed to. So when I got over top of the rivet, as I said before, the rivet just balled up. And at that point, at the point when it starts balling up, I was taking my filler rod and just kind of pushing the ball to the sides, trying to get it spread out of a ball shape. And essentially, some of the filler rod would melt and make the puddle bigger. So we had to crank up the heat a little bit. We had to give it a little more throttle up there and melt everything in. So, finally, you want to figure out the secret to that pretty weld, right? Well, let me tell you. After I welded all these, I went back and I grinded them down. Well, the ones that balled up into a ball that didn't fuse like they were supposed to, well, guess what? We had to re-weld them. And there was a handful of them that we had to do. So, what happens is, when I welded the first time, that cleaning action that I was talking about, that brought all the contaminants up to the top of the puddle and the top of the weld. Well, when I went back, I grinded it down smooth, got rid of the weld. Well, I got rid of the contaminants. I created a nice, new, clean piece of metal. So that second time when I went back and I welded it, well, it was a nice, fresh, clean piece of metal. And she welded, perfect. And I loved it. Okay, if you did too, make sure to hit that thumbs up. Remember, comment down below. And also, hey, I would love to do a collaboration with somebody. If you know anybody in the North Carolina area, yeah, I can travel a little bit, but I'm not going too far. But anybody else that does this kind of work, maybe welding, some hands-on stuff, I would love to work with them. If you see them, tell them, hey, check out my channel, or you can comment down below and tell me their channel. As always, remember, show some love, be a sub, click the red button over here in the corner of the video or down on the page. And as always, y'all have a good one.